Hi guys, and welcome back to Machine Learning with C++. We are now on section 3 and this is cluster analysis with k-means. So in this section we're going to look at what is clustering, and we're then going to be implementing the k-means algorithm. We'll then also be looking at how we choose k. Now don't worry about what k is yet, but we will be getting onto it at some point. So what is clustering? Video 3.1. Clustering is generally an unsupervised problem. So we don't train the algorithm, or we don't implement, or we don't, do anything to the algorithm before we run it on real life data. And it basically involves clustering the data into groups. So you could probably say there's a cluster of data points and there's a cluster of data points. Or actually you could probably say, well, maybe that's one cluster altogether and then this is another cluster. So there could be 2 or 3 clusters there. So basically, unlike linear regression where we're trying to predict something, clustering, we're just trying to find relationships in the data. So we're trying to, let the data speak for itself and see what the data comes up with. So k-means is probably one of the most famous clustering algorithms out there. It's an iterative process. It's very simple. I'm going to keep this video very non-mathematical because it's easier to get your head around if you don't really think about the maths. So it's an iterative process, and basically we keep iterating until we found k clusters within the dataset. So basically what we do is we initially start with some means or centroids, and then we assign for each data point, we then assign that data point the label of the nearest mean. So these 4, the closest mean is this one. So these 4 data points get assigned this class 1. Let's say these are class 1, and then all of these get assigned class 2. So what we've done then is we've then effectively segregated the data into different classes. Now then for each of the classes, we will then compute the mean or the centroid of this class. So for these 4, we are going to find the mean of these 4 points. And where this mean turns out to be, down here somewhere, because this one's all the way over here. In fact, it might be up here somewhere, but it's definitely going to be closest to these because this is where the majority of the density lies. So then once we've computed the new means or the new centroids, we then go through all the data points again and assign them to the classes. So you can see what's happened here is this data point here is no longer a member of class 1. It's now become a member of class 2. So all of these other ones are a member of this. I just left out the arrows so it didn't seem so overwhelming. So that's effectively exactly how it works. And the way we compute the distance is it's just Pythagoras, Euclidean distance. So you go your difference in x squared plus your difference in y squared, and then you take the square root of that to find the distance. So that's very simple, very intuitive. And then the mean is just you sum up the x and y values and divide by the number of classes. So again, here is the algorithm. So you assign initial means, and while it's not converged, assign the labels, and then you compute the means of these labels, and you keep doing that for each of the k classes until your means don't change. And that is effectively the k-means algorithm. So I hope that was a very kind of, brief and intuitive introduction to how the k-means algorithm works. I very much tried to shy away from the maths in that presentation. I hope you appreciate that, or maybe you don't. But hopefully you've grasped roughly how the algorithm works.